we based out at the Jaipur. So it is all about the Incube. And now I am handing over again to Ms. Astha Sharma. Over to you, Astha.
Thank you, sir. And now I would like to invite our first speaker for the event, Mr. Lalit Tiwari ji, Deputy President EHS and Group of Chief Sustainability Officer ESG, Kalpataru Group of Companies, to speak about his topic, Key Targets and Commitments for Environmental Sustainability. Sir?
1 moment. Okay, so let me first check the sorry. रास्ता कैसे करते हैं इसको?
Sir, in the bottom line, there's a rectangle there. जिसमें एक arrow बना हुआ है. Please press that
window है.
And it will open the tray for sharing screen.
Or you can press Control Shift capital E. Or at the top you can see. At the top पे भी एक arrow है.
Arrow पे तो कर ही रहा हूँ. Anyway, let me first introduce myself. Good afternoon, ladies and gentlemen. It's a great pleasure for me to start this session. And we have a very renowned faculty, Mr. Milind. And thanks to Kalender, who has provided this kind of opportunity to interact with you. And it is a very burning issue nowadays. I will not take much time. I'll just quickly throw some kind of burning facts and eye-opening facts, which you will see why sustainability is required. We have been hearing this sustainability for last many years, but the way we have been moving and the way we have been doing to sustain sustainable development, it was not up to the mark. Now it is a high time we have to do something for sustainable development. Sustainable development, what you must be thinking, what is sustainable development? Just connect. इसमें मुझे एरो नजर नहीं आ रहा.
Sir, you can see that there's a tray in the bottom area. वहाँ पे कैमरा का ऑप्शन है and माइक का ऑप्शन है. माइक के ऑप्शन की राइट हैंड साइड में एक रेक्टेंगल बना है जिसमें एरो है.
इसमें काफी सारी विंडोज हैं, तो वो विंडोज से करना पड़ेगा क्या?
यस.
Okay, fine. It is visible to everybody?
Yes, it is.
So friends, this is the subject which is a very, very touchy subject for all of us, especially for our this generation as well as for next generation. And I have already mentioned that we don't have a choice now to do something for environmental sustainability. So far, it has been at a corporate level, at a political level, everybody was talking about the environment protection, environment sustainability, but we have not done much as far as to secure our future generation. You can say future of the future generation. So let me talk about what is the need for sustainability. Can you everybody see that?
Yes, sir.
Yeah. So why we need a sustainability? You must be watching that population is growing, leaps and bounds across the world, and especially India, China, and Asian countries. And we have a limited resources with respect to water, with respect to energy, with like, and we have, because of the increased population, we are exploiting our natural resources. Natural resources are very limited. Either we are generating a power to coal as a limit. Okay, then we have a water, groundwater level. You can see nowadays, you can feel what kind of water quality we are getting. And earlier, we never see you can say our father or grandfather never seen any kind of RO and water filter. They were taking a directly water from the tape and they were drinking. It was a good quality, but it is you can see the impact of uh, bad environment. So that is the reason why we need a sustainability development. Slides. So there are three elements. If we cover the entire gamut of sustainability, what is sustainability? Sustainability means we have to protect the environment. We have to protect the society. Society means cultural, educational, political, health facilities, as at the same time economy, because we are growing very fast. Economy is growing very fast. So how can we adopt the best technology? How can we go for advancement to optimization of our resources, to protect our natural resources, and to go for a better substitutions? So that's a three aspect. If we combine it, then we call as a complete sustainability. If you break the sustainability, is a two words: sustain plus able. So means ability to sustain. What, who, and how long? It's a question mark. You must have heard that recently our Prime Minister went to Glasgow and there was a World Congress seminar. And the entire world community have taken a place there. By 2000, some countries had taken our Prime Minister has taken a
Hey, Laliji,
2007.
1 minute. 1 minute. Can we have a full screen? Uh,
Yeah.
yes, yes. Thank you, sir. Thank you. Sorry for interruption.
So the point is here now everybody is concerned with respect to conserving our natural resources. And as I already mentioned that we are very brutal with respect to exploiting our natural resources. And we are every day it is getting depleted. So now coming to the sustainable development. The question is how to protect our future generation to meet their own needs. Today, if we are not going to back up immediately, then our future generation will not tolerate and will always say that whatever we have given with respect to material world, it is not going to work for them. They will not pardon us. So what's sustainable development? Resource and energy uses, technology development, direction of investment, social, as I already mentioned, these are three aspects. This is the natural step funnel. If you can understand very quickly that if we go life supporting resources decreasing, which are happening now. So our life supporting resources are flourishing. If life supporting resources are decreasing, whatever we are sourcing, we are consuming. If we are reducing the consumption level and we are going for protection there, so our life supports are going to flourish. And if we are consuming, exploiting more natural resources, then demand for resources sustainable. It is requirement. So that is a modern concept. It all connected to social, economy, equitable, viable. You cannot take out any part of from these circles and go for a sustainability. tight post for the sustainability. What activities we need to do? Use material in continuous cycles. What is a continuous? Earlier we were following the linear kind of cycles. Now we go for the circular cycle, circular economy, where what we are using material, we have to use for 3R, recycle, reuse, and recycle, reuse. I'll show this on another slides. Activities are not sustainable when they are required continual input non-renewable resources. We are dependable on non-renewable resources. Use renewable resources faster than rate of renewal. We have a limited renewable sources, so they have some time to get renewed. So we have to be very quickly use the rate of renewal. We have to increase that. Cause community degradation of the environment, require resources of quantity that could never be available for people everywhere, lead to extinction of the other life form. So what we need to do out of box, and it is ladies and gentlemen, let me tell you that these are changes are happening at your home, at your company level, at your social level. Earlier, we never used a five-star electronics equipments. Now we are going for market in the market to buy a five-star energy consuming equipments. We are going for a water resources kind of thing. So that's happening everywhere. So 3R, I already mentioned that. How can we go for natural resources or renewable? Reduce, recycle, and reduce. Some waste still will be there, but it should be minimal. Maximum we can use for whatever waste we can go for recycle. We can nowadays people are producing even energy. They are making another product. So that kind of concept we need to go. It's called as a circular economy. Now, some eye-opening facts. Water crisis in India. You can see that's a fact. You go to the any site and you will find the what kind of water quality we have. You can see the right side, New Delhi, south, and other part. It's a highly contaminated water. We are not able to get a pure water, and water quality is getting down. Groundwater is because going very down. We are exploiting the groundwater nowadays. Government has already banned, so you cannot go for groundwater without proper approval. So already this a subject we have discussed: sustainable development, existing requirement. This is the concept we need to go. We have a two kind of population in the world. One is 5 billion people are using only 20%, which are undeveloping countries. You can say little developing countries. Another 1 billion population consuming 80%, like developed country. US, I have been there, and people are. US is the highest country. I mean, this is the country which is generating highest CO2 emission because any home you go there, they have a 5, 6 cars. Everybody is using a different car, and the average is mileage is also very less. So US is the maximum. US, UK, these are the developed country. They're using 80%, 1 billion. So this is the facts of life. Another challenge. Next 30 years, what is going to happen? Please understand these slides. Our energy consumption is going to increase 1.5%, 1.5 times. 1.5 times whatever we are using X gigawatt or megawatt, whatever, is going to increase 1.5 times in next 30 years. And what we need to do as per the global warming as well as per the our commitment to the global economy, we need to reduce half CO2 emission. Which don't you think this is a big challenge? If we calculate, it means we have to go for 3 times more efficient. 3 times more efficient, which is a big challenge but possible. Are you getting the slides?
Yes, sir. Yes, sir.
So what is happening? Who is the maximum consumer? Industrial sector is using maximum energy. Energy can be saved up to 5 to 30% there. If we go for optimization, energy efficient equipments, or go for a renewable energy, 5 to 10% energy saving by following the best operating practices, and 10 to 30 for using energy efficient system. 20 to 30% potential of water saving. We have a potential opportunity to adopt solar power and other green power. Another aspect. This is you can see the water is a global concern. Nowadays, you can see the Ukraine and Russia is fighting each other, and they are putting everybody's on different, very challenging environment. Economy is badly affected, but these people are not able to understand. Coming years will not get up. There will be a not world war. There will be a water war because water quality is going to. We are not able to get a water. Most of the two-third population is not going to get a pure water. 60 times 6% increase in global water usage since the 1990 because of the population again. Are you aware that one set of jeans which we are wearing, they need, our manufacturer needs 10,855 liters to make the one jeans. And we are not aware, we are just, you can see the, severity of this aspect. So 1.1 billion people do not have access to safe water, according to World Bank. 45% of water is lost due to the leak. Everywhere you will see the pipeline leaking. Water is at home even. We are using a washing machine, which has a more water consumption. So that's the most serious challenge in coming years, in next 10, 20 years even. Even you can realize that in our societies, we have to call water tankers. Earlier, that wasn't a scenario. We are getting water 2 hours in a day. Earlier, it was not a scenario because we were not aware, we were not understanding the kind of natural resource we are exploiting. This is the water scenario in India. Surface water almost polluted, groundwater almost depleted. There was no groundwater. Rainfall, we are not doing proper rainwater harvesting. It is getting wasted. And if we want to collect, then we need a proper treatment. Industry is growing. Water requirement is increasing day by day. And there was no water recycle, very less. Only 2%, 1% water is being recycled. There was a model in Singapore. Guys, you will be surprised that the entire Singapore country is using sewage water for drinking purpose. Entire Singapore. And this is the model now is being adopted by Saudi Arabia and Middle East countries. Population is growing, demand is increasing, quality of water is very poor, health issues increasing. So you can understand what is the future of water future in India. So finally, I will not take much time. New concept is coming up, net zero. What do we mean about net zero? If you are taking something from the nature, we have to offset the quantity which we are consuming. Net zero means net zero water. Whatever water we are consuming, either we need to recycle, reuse, so we can maintain the nature balance of the nature. Similarly, waste, whatever waste we are generating from house, from home, there are so many technology available. Entire waste is being used in various ways. So we have to go for entire waste. We need to recycle, reuse. Third one, energy. We have to go for a green power. renewable energy. We cannot afford to go for, uh, I mean, a coal-based plant energy. We because it is generating a CO2 in the atmosphere. So what is talking about the net zero? This is the agreement most of the countries have done this in recent conference in Glasgow. I think it was in October or November. Sorry, January. January. Correct, Shailendra? So let me talk about the Kalpataru. What is the Kalpataru is doing? We will talk about this. This is the some facts, more facts. 1.1 lakh death by food flood in the 6 years because we don't have a proper controlling water. We can recover the water we can use for recycling. So that's entire construction is going on. So there was no drainage system. So flood. 55, 58 billion sectors of crop damaged. 811 lakhs house destroyed. 469 trillion total economy loss because of the climate change. These are the all because of the temperature increasing, global warming increasing, pest increasing, and water pollution. We already discussed 30% of water is India contaminated, and 37.7 million. These are the data we have taken from the authorized sites. We see the impact. Air pollution. You have seen the daily condition. It is visible every year. What is happening here? Even nobody wants to travel in Delhi during winter season. People are affected badly, and they are spending lakhs rupees on their treatment. So, so global risk. This is the I already mentioned that entire global is very concerned on the world economy. There's climate action. There are extreme weather, biodiversity losses. There are some livelihood crisis. These are something which I will not go to this one. I think that's something which we need to do with respect to global warming. If we not do immediately, then in India, 5 cities are going to sink in the water very quickly. Not by 2050 is not far away, and Mumbai is one of these cities. The Sustainable Development Goals, which has been defined by the Global Congress, United Nations. 17 goals, 169 targets. I will quickly, I will not take much time in this case. So, Shailendra, I think from my side is enough because another faculty is there.
Yes,
Let
sir.
him take the next session. Thank you, guys. You have any question? Anybody has any question?
You can write your question in the chat box.
I will address your question.
Or you can also raise your hand. We can unmute you.
Asta, you can take any question, any question if you have.
Yes, sir.
Because Million is taking a session now, so I will not take much time. Let me address a couple of questions.
Yeah. Okay. So, do anybody have any questions? I guess no.
Okay.
Thank you so much, sir, for explaining this topic in such a simplest way. And I understand this is one of the most important topics that we are coming across. Uh, And now I would like to invite our second speaker, Mr. Milind Chittawar, CEO and SEE Tech Solutions, to explain us about deep energy retrofit and its opportunities and cost saving. Welcome, sir. Please go ahead with the topic.
Thank you very much. Thanks for this opportunity. I can share my slides. Is it visible to everyone?
Yes, sir.
Yes, sir.
Yeah. So friends, what we are going to discuss today is how different retrofits opportunities are there for energy savings. Right. So first of all, what is a retrofit? Retrofit means your existing machinery or process equipment or the utility that remains same, right? So you change something in that, you modify something in that, and that is called as retrofit, because that's the way you achieve very good payback. So we have been in the business of identifying energy saving project and actually implementing them with a guaranteed saving route. So our tagline is delivering profits and sustainability together. I have only one slide for telling about our company. Then we will go to different technologies. So we started in 1993 way back, and we are headquartered in Nagpur, working all across India. Then we developed knowledge-based software solutions, CUT-Save, C-Thermisave. These are used by the auditors and the energy managers for identifying and quantifying energy saving opportunities. We achieved grade 1 ESCO from 2013 to 2019. That is from Bureau of Energy Efficiency, Ministry of Power. Right, we have a present team size of 50 plus engineers. And what we do, we basically target to achieve at least 20% savings in existing building or existing manufacturing setup. Right, and if we are addressing only utility, even in that situation, we would look forward to identifying at least 20% energy savings in that. And then what happens is we have basically around 30 technologies in our basket to implement them. But for a given location, we would be identifying around 6 to 10 technologies, right? Because by any one technology, you cannot get 20% reduction in your overall energy cost or overall energy consumption, right? So we need to implement at least 6 to 10 technology to arrive at that. And this is electrical energy as well as this is thermal energy. Right, and we are assisting companies to achieve net zero target in the most economical manner. So now coming to this retrofit technologies, right? So these can be as simple as automatic power factor controller or demand controller, right? Then IE5 motors, IE4 motors, energy efficient pumps, right? Then replacement of diesel or CNG, right, for laundry and hot water. We have done several such projects for hotels. In Jaipur also, we have worked for Taj Jaipur. Then heat pump, LED, then energy efficient exhaust systems, then EC fans in AHU. This is a very good technology. Then there is a technology called as double effect evaporative system. In that we are able to achieve much better cooling, right, than normal evaporative cooling. Then using desuperheater to preheat the water and also improve performance of chiller. Then auto tube descaling system, right? So we will see them in detail in subsequent slides, but I thought that let me list out them here. Then there are very advanced chiller controllers are there, right? And then what happens is most of the time utilities are continuous. Like for example, there is a boiler, right? So if the steam is getting consumed, so boiler will go to the firing automatically, and as the pressure is achieved, the boiler will go to no fire kind of a condition, right? Or low fire kind of a condition. Same thing happens with compressed air. Same thing happens with chiller. However, in many applications, the utilization is in a batch process. This particularly happens in the process industry. So there, the mismatch of utility and batch processes provide us very good opportunity for energy saving. So let me first take a case study, right? So this is Taj Suraj Kund. Here, with an investment of around 2.33 crores, energy saving projects were implemented, and um, uh, corresponding savings were achieved with a ROI of 85%, and GHG emission reduction was 2,373 metric ton per year. Now, what technologies we implemented here, right? So here the technologies were implemented. They are chiller controller, right? Then CTI approved cooling tower, right? If our existing cooling tower is of a lesser capacity, your chiller is going to consume much more power, right? Then variable frequency drives on the AHUs, then LED lighting, then laundry was completely revamped. The thermal fuel was completely stopped. It was all converted to electrical. Then auto tube cleaning system and heat pump. But friends, what happens is customers are not ultimately interested in the technology. They are interested in the results, right? And how we have to demonstrate the result. So this green line, what you are seeing on your screen, is the baseline, right? And these are the 12 months on the x-axis, right? So ultimately, you have to bring down the cost, right? So here you see a dark blue line and a dark orange line, right? So the energy conservation projects, all whatever were implemented earlier, they were monitored, savings was monitored, and then the consistent savings, right, across months in 2 different years, that was monitored. So this is how the result needs to be demonstrated, because then and only then the confidence on the energy saving that happens. You may implement any technology. The analogy almost works like doctor, right? We go to doctor. We are not interested in any specific medicine, right? We are interested in getting all right, right? And doctor will examine, doctor will do the diagnosis, and then doctor will give us a prescription, which will have, let's say, 4 or 5 medicines, right? And then we take them, and then we get all right, right? So that's the kind of approach is needed in energy efficiency retrofit projects, right? Because whatever project we may do, right, we will have to demonstrate the savings. This is the another case. The above line was energy cost before implementation of the project, and the below line, right, is the actual energy cost after implementation of the project. So I repeat, it doesn't matter which technology you are applying. Like in this screen, you are going to see so many technologies, right? So energy efficient technologies, particularly with retrofit options available, there are as many as medicines available in a medicine shop, right? But you have to figure out which is the right technology for a given location. You have to implement that. You have to make a baseline before implementation of the project, and then you implement the project, and then you demonstrate the savings by comparing on the baseline, right? So that is what is most important. So here it is on the left hand side on my cursor is a auto tube cleaning system display. What happens is in chillers there is condenser, right? But in this condenser, basically TDS, that is the total dissolved solids in water. So that deposition keeps taking place. So the heat transfer gets lower and lower, right? So we have to continuously clean them. So the moment you clean it, right, you will find a reduction in the condensing pressure on your vapor compression side, right? But that is a one-time process, right? Then again, it is done after 6 months or after 3 months. So this is a continuous cleaning system. So by doing this, there is a resultant savings of almost like 4% to 10% has been seen in the chillers. Then we have listed their EC fans. So in the EC fan, you'll find that the motor, right, and the fan, right, they are all in one simple assembly, right? There is no belt drive, so you're not losing anything. And then there is a option for speed control also in the same assembly, right? So what you're getting is you're getting a drive, you are getting a motor, you are getting a fan, all put together, right? And its speed is controlled based on the temperature that is needed. So the energy saving is very high, right? These are 2 heat pumps, right? And in heat pump, what happens is you are basically generating hot water, but on the cold side, right? Instead of just providing a air source heat pump. What you do is that you provide a water source heat pump, and that water source heat pump gives you chilled water. That chilled water, you put it to the chiller line. Then what happens is the chiller consumption also reduces. So there is a double benefit. One is that you save it on the thermal fuel, right? And with the diesel cost going so high, right? The savings are phenomenal through the heat pump. But instead of making it air source, you make it water source. So whatever is the resultant saving, that gives you additional saving on the chiller side. And what happens is your actual chiller operates on a lesser load. And when you reduce the loading on your chiller, your performance also improves. So like this, we have to, like what happens is in the medicines we say, what is the effect of this medicine, or what is the effect of these 2-3 medicines when they are taken together, right? So there is a combined effect. So when you are implementing multiple technology, there is a combined effect, right? So accordingly, we have to get the right energy saving amount, because with every energy saving technology you are implementing, your baseline is getting reduced, right? Then this is a picture of dynamic controller, right? This is installed on the chiller, which works on artificial intelligence based methods, right? And gives us savings, right? And these are all the pictures of actually implemented project. Then this is a conceptual picture of the evaporative condenser. In evaporative condenser, what happens is your condenser and cooling tower, they are all brought to one particular equipment, right? So here, even if you change a water cooled condenser by evaporative condenser, you save energy in on the compressor as well as the pumping power. And when you are replacing a air cooled condenser, right, with the evaporative condenser, you are going to save a significantly high amount. So all these kind of technologies requires a very good amount of competence to implement the project. Then this is on the second line is a cooling tower, CTI approved cooling tower. Now what is CTI approved cooling tower? CTI approved cooling tower is Cooling Tower Institute, right? They have come up with a specific design, right? So these cooling towers are costly, but if you make a smaller cooling tower, your energy consumption in the chiller is going up and down, right? In one of the example, we will see what is costly, whether the equipments are costly or whether the energy cost consumed by these equipments are costly. We will see it there, right? Then we had discussed that the utilities are continuous, but the processes are batch process. So in laundry, what happens is the steam generation in the boiler is continuous, but whereas the laundry operates in batches, and that too for a few hours, right? But for that, boiler keeps running for 24 hours, right? So we provided here, we shifted to electrical. Electrical heating is very costly, right? But the distribution losses are so high that by providing a distributed steam generation source, we got here. So this is not a energy efficient technology by itself, right? But sometimes what you have to do is that you have to take a holistic approach and come up with solutions, right? Then at another location, the voltage fluctuation was very, very high, right? So we used the servo stabilizer as a energy saving equipment, right? And then a replacement of old motors by energy efficient motors. And nowadays IE4, IE5 motors are available, which gives us a phenomenal saving. So moving on to next slides, right? So as we said that the number of technologies are so unlimited. It is exactly like number of medicines available in a medicine shop. But you have to get down to those few technologies, right? So this is another list of technology, right? And this is the applicable industry, right? And this is the actual savings achieved by implementation of those technologies, right? And then what happens is, even if a particular technology is having a particular potential for energy saving, but what happens is in a given case, the actual energy saving is going to be different, right? It is never that it is exact. Like for example, if you change a 10 watt, if you change a 100 watt bulb by let's say 12 watt LED, so this 100 is fixed and 12 is fixed, right? But other than lighting, in none of the other applications, your actual energy savings are going to remain fixed, right? So very good amount of competence is needed to even identify, quantify, and implement. That is necessary. So I'm moving further, right? Now let us discuss one of the retrofit technology which is getting very popular, right? That is usage of IE4 and IE5 motors, right? Friends, the development in energy efficient motors has been very recent and has been very fast, right? Like for example, from I1 motor to I2, it took a lot of time, many years, right? From I2 to I3, it came very quickly, but then now we have I4 and I5. Even for flame-proof environment, I4 motors are available, right? So on the this is one of the process plan, right, wherein all of these, I mean, the top two pictures are basically pumps, right? And on the third picture, there is a agitator, right? So let us see this, the first pump. So this was the existing motor, right? So here, the green color motor, which is a I4 motor that was fitted here, right? And it resulted into 12% savings, right? Same way in the 7.5 kilowatt motor, right? We wanted speed variation as well, right? And here the feasibility for I5 motor was better because I4 motor will also give you saving, I5 will also give you saving. But your fine levels of calculations will basically give you a feedback that which one is more feasible technically also and financially also, right? So then you make a fine choice of that. So the 7.5 kilowatt motor resulted into 18% savings, right? And here this is the gearbox, right, for the 1.5 kilowatt motor, right? And then the motion or the rotation is getting into 90 degree, and then this is the agitator where this agitator is rotating, right? So this was 1.5 kilowatt motor. So this was again changed by a I5 motor, and it resulted into 30% savings. So what happens is, particularly on a smaller motor, you get higher percentage saving, right? But the cost of the motor on a smaller size is much higher, right? Whereas on the higher kilowatt size motor, you get percentage saving was less, but the cost of the motor, I mean per kilowatt, the price of I4 or I5 motor reduces, right? So practically you get similar payback period, despite your percent savings are so different. Your payback periods are usually around 2 years for doing these kind of projects. Let's see further, right? There is a pulley drive. In this pulley drive, you can see the old motor, right? So this was retrofitted with the energy efficient I4 motor, right? And here the existing motor was of 3.7 kilowatt, but then the load was measured on that, and then it was found that the motor size also can be reduced, right? So size optimization is also a very important process. So here we replaced it by 2.2 kilowatt for I4 motor, right? Now what happens is the synchronous RPM, right? Those who are from electrical engineering background, they will understand that the RPM of this motor is 1450, but whereas RPM of this motor is 1500, right? Now if you install a VFD drive here, right, the cost of the drive becomes very high, right? So what you have to do is that accordingly you change the pulley size, right? So both of the pulleys were changed, right? These pulleys are changed. This because end of the day, what you have to do is that whatever motor you put here, your shaft must operate at the same speed because their production requirement must not change, right? And when it was implemented, right, the unit consumed over a period of I think in this case 5 to 6 hours we monitored that, right? And then the difference in the unit consumption of both of the motors we can see here, right? And these savings were around 23%, right? The unit saves per year and rupees saved per year, and accordingly the payback period, right? So this much level of detailing is needed in implementing any energy efficient retrofit activities. Let's see further, right? So this is another agitator motor with I1 motor, right? And the old motor was 2.2 kilowatt, but the measurement demonstrated that 1.5 kilowatt motor can be provided there. So this new motor of I5 is of 1.5 kilowatt only, right? And then this was replaced. Then this is how the savings were there, and around 30% savings were obtained. But what happens is if you compare their nameplate efficiencies, right, then you will not find that the saving potential is so high because at full load in the nameplate you get full load efficiency, which is almost at 100% loading. So at 100% loading, you will find that the difference in I1 or I5, right, is hardly 3 or 3.5%, right? So then you will find that then you will calculate this 3 to 3.5% in your payback, right? And then you will find that the energy efficient motors are not at all feasible, right? But whereas the actual savings are pretty high. So why are these savings are very high? Because at lower loading, motor efficiencies are extremely poor, particularly for I1 or I2 motors. The part load efficiencies are very, very poor, right? Whereas this I5 motor has a very good part load performance characteristics. So like this, we need to get much, much deeper into every energy efficient retrofit technology, right? Now, for example, if someone want to buy a new motor, right? So should he buy I1 or should he buy I5, right? So a comparison is shown here, right? So on this graph, on the y-axis, you see efficiency, whereas on the x-axis, this is a log table. On x-axis, you will find that the motor kilowatt size. So as the size of the motor goes up, you will find that the motor efficiencies are going up. And these different lines are basically I1, I2, I3, I4, and I5, right? So for the same kilowatt, let's say it's a 10 kilowatt motor, you'll find that the difference in I1 and I5, right, is almost like 10 to 15%, right? But as the size of the motor goes up, you'll find that the difference in the efficiency level is less. So that is the reason we are getting lower percentage saving in the higher motor size, right? But because of the low cost per kilowatt, we get the same kind of payback, right? So let me explain you this example, right? There is an application, right, wherein we are trying to compare the base case, right? And then we are trying to change it by, instead of buying for a I2 motor, we are thinking of I4 and I5 motors, right? And these are the rated efficiency, right? 85%, 90%, and 93%. Now look at the cost of the motors, right? This is around 32,000, this is 45,000, and this is around 79,000. You'll obviously feel that when I can do my job with 32,000 rupees, why should I put 79,000, right? But friends, see the difference here, right? Operating cost of that motor, if you are going to buy I2 motor, is going to cost you around 3 lakh, right? Whereas with I5, it is going to cost you around 2.45 lakh only, right? So whatever is the incremental additional amount you are paying, that is 79,000 minus 32,000, that is going to get payback you in so less time, that is 4 months or 8 months, right? So learning number one, the cost is not in the appliance, or the cost is not in the motor, or the cost is not in the in purchase of an energy consuming equipment. The real cost is in consuming it, right? And finally, there is a concept of life cycle costing. Life cycle costing means if you compare a 10-year cost or a 5-year cost or a 15-year cost, right? Whatever is the life of that particular equipment. And then you see that if you are using I2 motor, then how much is the total cost you are going to incur, and how much is the total cost you are going to incur if you are going to buy I5. Now, exactly all these kind of concepts, all of us, right, apply when we buy our bikes or when we buy our cars, right? We are extremely conscious about the specific energy consumption of the cars, right? But the same process, right, when a industrial or a commercial building process equipment is bought, right, at that point of time, people making those decisions, their qualifications, their competence is very, very high, but we do not see such a level of detailing in terms of buying, right? So the benefits of going for I4 or I5 motors are phenomenally high, whether it's a new motor case or whether it's a retrofit case. Only thing is that you need to have operating hours more than 8 hours per day, right? Because if your sum of the load is operating just 1 hour per day, there's no point in changing that, right? Even if that is inefficient, there is no problem, because the overall energy consumption is very limited there, right? Now I'm taking another example of servo motors on hydraulic applications. There are hydraulic presses, right? You must have seen in manufacturing setups that there are hydraulic presses, right? These hydraulic presses are used to in forging equipment, right? You are trying to hit the equipment, hit the your product, right, which you want to forge it to a particular shape, right? And so here you will find that the there is a constant consumption, right? You are able to see this line. because the software output was very faint. Is this line visible?
Yes,
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 sir.
it is
Yeah,
visible.
yeah. So this is your useful power, right? So this is fine, right? We don't mind this peaks, right? Because every time the press is the hammer is put on it, right? So that is the hydraulic power is what you want to provide. But there is a constant consumption, right? So this constant consumption is your no load power, and that is so high, 4.7 kilowatt, right? And this 4.7 kilowatt is 62% of the cycle time, right? On the x-axis it's time, right? And on the y-axis it is power consumption, right? So when a load analyzer was put onto the motor, the actual situation comes out very clearly, and it's a 22 kilowatt motor. So what is the problem statement? The problem statement is that we are having a fixed loss, right? If a motor is used for higher efficiency, these peaks will be minimal, right? This overall power consumption will reduce, but the peak is occurring for a much lesser period of time. So here, more than energy efficient motors, the focus is required for how to save on the no load power, right? So many times in the automation, what is done is that whenever it is on no load, reduce the RPM, right? But while by doing that, what happens is the approaching or the receding, right? The hammer speed that goes down. So that is not liked by the process people. So what is the solution? The solution is a servo motor, right? Now here, I'll give you example of the servo motor. The servo motors, you will find that there is no baseline consumption, right? Or there are only peaks, right? So baseline is zero, right? In case of a servo motor, right? So this servo motor, you can immediately start it, you can immediately stop it, right? So that's the beauty of a servo motor, right? So when you want the stroke, right? So at that point of time, motor will move, otherwise motor will stop, right? So you are saving that power, right? Whereas on the there were same two types of machines in that particular unit where we work, and we demonstrated that you see this is a constant consumption, right? And then you are getting peaks, right? So you are losing your all the no load power consumption, right? Now same thing as for a retrofit application, you are not going to change the overall machine, right? So normal induction based pump, right, is replaced by a servo motor based pump, right, to give into this kind of resultant savings. And now you see unit consumption in 5 minutes, right, for the same level of production. This is 118 watt hours, right? Because it's only 5 minutes, that's why the consumption is in watt hour and not in kilowatt hour, right? And whereas here it is 341. So you just simply see that the energy consumption is more than double, right? And then there are several other motors. So the bottom graph gives you a comparison for the overall power consumption of that particular machine. This is only on the hydraulic motor, because you are going to do your project only on the hydraulic motor and not on the total power consumption, right? So here you see that the consumption is 274 and the consumption is consumption is 477, right? So this is the level of detailing that is needed in identification and implementation of any energy saving project, right? And from the process point of view, it has to achieve, I mean, same or better performance, right? The performance of a machine or the motor should never go down, right? And here the savings which are achieved are of 25 to 50%, right? Now, let me take the same concept of different retrofit technologies with a different way of explanation, right? So basically what happens is in this particular case, there was a electrical heater, right, for hot air purpose, right? And then the project which we identified was that instead of electrical heating, we can change the system by a uh, thermic fluid based system, which will be fired by renewable fuel, right, which is briquettes, right? So that's the project. So that project would look like this. There will be a centralized utility, right? So in some of the cases, you are making existing centralized system decentralized. In some of the system, you are making decentralized centralized. So there is no fixed way of doing it. For every case, there is a different solution, right? But the financial packaging of a retrofit technology is also very, very important, right? Because this is the annual energy cost saving, right? Which is around 69 lakhs precisely, right? And the project capital cost is around 1.15 crores. right? And monthly savings, the project needs to be financially so structured that uh, your EMI, right, which is around coming around 3.84 lakhs, is lesser than the monthly savings, right? So what happens is a positive cash flow starts for the customer right from the first month itself, and it doesn't go into the payback kind of a concept, right? Because in payback kind of a concept, everybody feels that I have to invest first, right? And then after 2 or 3 years, I am going to get payback, right? But if you financially structure this way, right, and let the financial institute invest into the project, even a higher interest rate of 12.5% can be absorbed very comfortably, right? And just from the month of project implementation, the customer starts getting benefits of around 2 lakhs every month, right? So it's not only that the understanding of a retrofit technology from the engineering point of view, it is important, but it is equally important to make a project financially feasible, right, by doing this part, right? And we have seen a very good attraction, right, in this kind of a situation. So we saw about evaporative condenser, right? So with evaporative condenser in the same financial model, what happens is the monthly EMI, right, works out to be around 58,000, but whereas monthly savings works out to be around 89,000. So there is a 30,000 rupees positive cash flow, right? So what happens is normally it is considered that the engineering department or the maintenance department is basically a cost side, right? Because to run a plant you require a cost, right? And but whereas what happens is in this way, right, the maintenance people can generate profit, right, for the company by reducing the operating cost. The same thing, there was an existing chiller system, so we decentralized that system and then provided different kind of chillers, right? So it included a centralized chiller like this, a VRV like this, right? And then a far away distance, right? There were air conditioning. So in a centralized system, there was a lot of loss because of so much of travel, right? And the operating hours were also low. So we simply provided a split air conditioner there in the faraway locations, right? Now, it is not only a concept of energy efficiency here, but the way you conceptualize the overall project. That is also very important. And even if you have done this successfully, the financial structuring of the project should be made successful. That is very important, right? So here also you will find that the monthly savings are around 3.61 lakh, right? But whereas the monthly EMI is 2.85 lakhs, so around 75,000 plus is a monthly positive cash benefit for the customer. So when these kind of offers are being identified and presented, the acceptance of the retrofit energy efficient technologies further improves. Right. So I thought that I'll share my experience of actual work done in the field. Right. So this is what I have from my side. Uh, any questions that you have, most welcome. I'm stopping the presentation. If there are any questions, most welcome.
You can write down your questions in the chat box. Well, I guess there aren't any. Well, thank you so much, sir, for throwing light on the topic, and I'm really glad that you came. And so now, if I would request you all to start a question answer round of the event. If there are any questions, please raise your hand, or you can write your questions in the chat box. We have a question, sir, from Mr. Farhan Malik, and his question is: are there any incentives in tax also that can be adjusted through the energy saving projects?
Yeah, definitely. Basically, there is a faster depreciation rate, right? If you take up an energy efficient project, so earlier there was almost like 100% depreciation was allowed, but nowadays 40% depreciation is allowed for most of the energy efficient equipments. The IT Act clearly identifies what all equipments will be considered as energy efficient equipment. So you can get an accelerated depreciation of 40% instead of normal. What you get is 15%. So it's there.
Okay. Sir, we have a candidate who would like to talk to you, and
Sure.
that
Everybody
is
is most
Mr.
welcome.
Yeah.
In energy efficiency domain, you can talk to me on anything. Yeah, please.
Yeah. It's Mr. Vinod Kumar, and just
Hello, good
yes.
afternoon. I am V.K. Lohadia, accredited energy auditor and doing practice in Jaipur. Actually, I want to just have more details about the double evaporative cooling, which is ideal for Rajasthan to replace the normal air conditioners. Can you just elaborate more what is this double evaporative cooling system and how it works? Is it a cold air coming out from the
Your voice
source?
voice is not clear. Asta, can you hear the voice? And then you
No,
can
sir.
tell me.
Mr.
Okay, I
Vinod,
repeat my
Your
question.
voice is not clear.
Okay, I repeat my question.
Yeah, please.
Is it audible now?
Yeah, it's
yes,
better.
it is.
Bit better. Yeah.
It is better. I am V.K. Lohadia, accredited energy auditor, and I am practicing in Jaipur in the name of PSU Energy Services. I am also from BW accredited energy auditing team. Based in Rajasthan, actually, I was more interested in the double evaporative cooling system, which has the potential to replace air conditioners, which is consuming a lot of energy
Yeah.
in peak summer in Rajasthan. If you can deliver more, say more, what is that, and how it is cost-wise as compared to the air conditioner? What is the actually fundamental activity which we are doing in cold air?
Let me
Air
repeat.
is coming back to
Yeah.
the another system.
Let me repeat your question because again the voice went down. You want to you raised the point of double effect evaporative cooling system. Am I right? Is this right?
Yes, yes, you are
Okay.
right.
And what's your question on that? Just in one line.
Actually, how it works and what is the
Okay. Yeah. Sure.
what is the principle and how it is cost-wise comparing
Sure.
in the
Great.
operating cost and
Great.
in the
Got
capital
it.
cost capex?
Sure. See, what happens is in a evaporative cooling basically works in between DBT and WBT, right? Because
Yes.
WBT is lesser than DBT, so you evaporate water, right? So based on psychrometry, you will get the cooling, right?
Yes.
Now in this case, what is being done is that the first is air is pre-cooled by a cooling tower output water, right? So cooling tower output water is much lesser than the DBT, right? So this is basically a sensible cooling, right? So what you are doing is that first you are doing a sensible cooling and not the latent cooling, right? So when you are doing a sensible cooling, so it is basically a heat exchange, right, between water which is inside the tubes, right, and the air which is outside the tubes. So it is getting sensibly cooled, right, in first stage. So that's the first effect, right? And in the second effect, it works like a normal cooler, right, wherein you are evaporating the water in the air, right? So this is the way you get much closer temperature to WBT, and you do not add that much of moisture, because if you keep on adding moisture, so higher moisture will create a discomfort, because more than 60% humidity, even at a higher
Yes.
temperature, makes it discomfort. So this two-stage cooling, right? There are many manufacturers which are there, which are now providing this, right? And for a larger area, when the working hours are very high, right, particularly in office cases, right, many new offices, right, like for example in our office at Nagpur, right, we do not have air conditioners, right? So leaving few months of rainy seasons or few days of rainy season, I would say, because Nagpur is a very hot climate, right? So here we are getting very good result through this.
Okay, so it means that cooling tower output water is to be used for sensible heat
Sensible cooling.
removing first. So you will have to add another equipment like cooling tower in that, and then that air is used again in that
Yes,
system.
yes, correct.
So the operating cost or operating power,
Yes.
how much, say 1.5 times?
Maybe, I mean, almost. I mean, operating power becomes almost 33% of it. So 2/3 is saving almost.
So can you share the list of the vendors who have done it? Because in lot of industries which in Bhilwara and
I'll
in
suggest.
Barmer.
Yeah. I'll tell you right now, right? Because tomorrow onwards I will be traveling, so I may miss out that. So you simply write a double effect evaporative cooling system, right? You'll get 2-3 names, right? And if you are not getting it, kindly route it through the organizer. I'll get you that, right? Asta, please.
Well, which company double operating
I
cooler you are using in your office?
I do not remember the name. I do not remember the name, right now.
And how many years you are using it?
Using it from almost like now 7 years. 7 years now. It's an older one, right?
Okay.
Yeah.
I think this information will be useful for many people.
Sure.
In offices and also
I'll mail the names to the organizers, right? They can then forward it to you. Yeah.
And what is your observation on the what you called light pipes taking the sunlight inside the working atmosphere?
Got it. Yeah. So what happens is in a new building you can apply that, but in a retrofit case it is very, very difficult, right? In an existing building, applying concept of a light pipe becomes very difficult, right? But if it is an industrial shed, right? Like for example, if there is an industrial shed, right? So then you can have light pipe. But in industrial shed, what happens is you can anyway put transparent sheets, right? So light pipe is a good concept, right? It can be applied.
No,
But
I'm talking about the parking area in the malls, new upcoming malls, new upcoming hospitals. Where the parking is there at the 2-3 levels, and then all the time the lights are being kept on for safety reasons in the parking area.
So what happens is this is going to save your time during the daytime only, right? During night time anyway, you will have to provide lights.
Yeah, that is there.
Another concept I actually wanted to emphasize is that every energy efficient technologies is finally rupee invested versus rupee saved, right? So when you look at rupee invested versus rupee saved, right, on that aspect, the light pipe are very costly things.
Is it?
Right? Yeah, of course, because today first of all lighting consumption is very less, right? In that lighting consumption, the LED, the moment you put LED, again the lighting consumption goes down, right?
I'm talking about the parking area in the picture halls and the malls which are working in the daytime mostly.
Yes, the cost of the light pipe would be significantly high because you will have to undergo 3 floor underground, right? So the light pipe traveling to 3 floors underground is a very costly affair. Yeah.
Okay.
Yeah. I can take next question.
Yeah, thank you, Vinodji. And the next question is from Asim Musallam, and he's saying that how we can evaluate the existing motor efficiency. Let us say water pump. So
very good question. See what happens is theoretically methods are there for evaluating motor efficiency, which you can do it only in the labs, right? And that is in all practical cases that is just not possible, right? So what we did was we developed a software in that we provide efficiency values at 75% and 100%. Again, because of rewinding what is the drop-in efficiency of that particular motor, that is also not known, right? But this method helps us, and then we take the operating power, right? And then through this software, we try to calculate what is the efficiency, right? But particularly what you can do is you can it's not necessary that you should use the software only. You go for the motor characteristics for that particular motor, right? Every manufacturer provides you load characteristics for that particular motor, right? So you'll find that convex shape curve, right, for your motor, right, in which percent loading will be on the x-axis and y-axis will be your efficiency, right? And how much is the motor input kilowatt right now, that you can measure, right? So just see what is the percent loading on that, and then you just go up. So that much will be a reasonably correct estimate of your efficiency, existing efficiency. But here it cannot take account of number of rewindings and the quality of it. Yeah, but you can clearly understand that a good energy efficient motor operates at a very low efficiency at part load. That understanding can definitely be there.
Sir, we have Dinesh ji also, and he raised a hand, and I will now allow him the mic.
Oh yes.
Hello, Mr. Dinesh.
Yeah. Hi, Milind. Dinesh here from Dubai. My question is that in terms of ESCO projects implementation, and a lot of barriers are there, advantages as well as barriers in implementation. I mean,
So what's your question?
technical barriers, which
I couldn't get that.
Yeah, the question is more. Yeah, what are the typical technical and non-technical barriers? An ESCO like
Very good. Got it. Very good question. See, what happens is you try to make any change, right? Any energy efficient project is asking for a change, right? And any change is first of all resisted, right? There will be umpteen number of reasons why a particular project cannot be done, right? So the first thing we look into our customer is that the customer must have a very strong desire to reduce his energy cost, right? It must be their very strong need, right? Okay, so that's how we take the first thing, right? And then second thing is that then all other things are in your domain, right? Because your identification of the project has to be correct. Then your implementation also, you have to take the responsibility, right, of delivering the claimed savings, right? So that is the level of technical knowledge you need to have, right? So that technical knowledge is also a big barrier. And then even if your project is identified right, it needs to get implemented also right. Okay. And for example, because of Corona, now the baseline is not available. Like those examples which I showed you were before Corona period, because in Corona the building was completely closed, right? So there is no baseline available, right? So how do you do that, right? So right availability of a baseline also becomes important. But in that case, as far as motor efficiency is concerned, you can straightway go for a instant kilowatt before and after, right? So that kind of a monitoring and verification of savings, that method you can apply. So it's a whole big field, right? And there is only, I mean, any one reason is sufficient for failure of a project, right? Or customer not going ahead with a particular project, right? So it's a whole big cycle, right? And which one can learn by experience only. Yeah, I don't know whether I answered your question or not.
Yeah, you answered. I just have one question in addition to this, is that did you find a customer looking at your proposals in terms of guaranteed saving or shared saving proposal? It's too good to be true. For example, he doesn't have to invest anything, and he's going to get like 100,000 rupees, or it's like something like a scam or something to begin.
Right. Now what happens is
they don't have to invest anything, and they're getting some money.
Actually, that's what is the feeling about ESCO, right? ESCO would come, ESCO will invest, and ESCO will give saving, and then only ESCO will take back, right? But the point is, this is a very incorrect understanding about the ESCO. See, what happens is when you are investing, right? It is you means any ESCO is investing, then it becomes ESCO's right to choose a company, right? Okay. So in that case, what is happening is ESCOs are choosing very high credit worthiness kind of customers, right? ESCOs will not implement the project for everyone on a shared savings model. Why will they? Because if credit worthiness is not there and the ESCO has done all the implementation and investment and customer is not paying, right? So then because legal system in country is quite poor. I mean, it is getting improved, right? But if you see ease of doing business, India's rank has improved, overall rank has improved a lot, right? But one of the parameters is enforcement of contract. So enforcement of contract, the Indian rank is still very poor, 163 in total numbers of 190, right? So what point I wanted to say is that if any ESCO is investing, it is completely that ESCO's prerogative to select the customer, right? So ESCOs would not be investing it for everyone. That is for sure.
Thanks, Milind. This was a great presentation.
Yeah, my pleasure.
Moving on, we have another question from EDS Global, and his question is to you. You mentioned chiller controllers in Vivanta. Can you please elaborate or describe on the control strategies or logic used?
Yeah. See, what happens is, how does a chiller operate, right? A chiller will operate, you will set the chill water temperature that you want, right? So that chill water temperature, for example, is set um, at a range of 10 degree and 12 degree, right? So at 10 degree, your chiller will stop. For simplifying, I'm taking this case, right? Because chiller gets lesser loaded, right? So that becomes very difficult to explain. So at 10 degree Celsius, the chiller will stop, and at 12 degrees centigrade, chiller will switch on again, right? So for simplicity, I'm saying this. Now, this set point is meant for all the 24 hours, because during daytime there is a lot of sun load is there, and that sun load is also variable, right? Then there is a occupancy level that is also continuously varying across 24 hours, right? Then during the night time, the energy release from human being is much lesser, right? So what is happening is your set point is constant, right? For across 24 hours, for across season, for across or at the most in winter, what happens is we will put a higher set point, or in summer we will put a lesser set point, but again it is fixed for that day for sure, right? Whereas this artificial intelligence based chiller controller supersedes the existing control system, right? And on that controller, right, it tells the chiller that you operate on this number and not on that number which is there, right? And it makes that kind of a profile based on the history of inlet water temperature and outlet water temperature. So if the load on chiller is less, the difference between these two numbers, inlet and outlet, starts reducing, right? So like that, chiller controller works on a artificial intelligence based kind of a thing, right? We are not the designer. Like, for example, any doctor does not know how a medicine is manufactured, but he knows very well that if I give this medicine, that, and because my diagnosis is right, I'm going to get this patient right. So that's how the competence of any ESCO company should be there, right? There's no point in getting inside the product, because that's not my competence. I'm not an electronics guy at all. I'm not at all artificial intelligence guy, right? So what happens is we take several trials, right, before qualifying a particular product or before qualifying a particular technology, right? And then we have to build analogy how to quantify the savings, right, in a given case, right? Because if you look at Bureau of Energy Efficiency books, or even my qualification of certified or accredited energy auditor, or several others, right, there is no method available for quantifying these savings, right? But whereas for customer, we will have to give ROI, right? But you develop that analogy with your experience. So that's how it operates. And it's a very, very good equipment. I mean, on ROI side, we have found it much better. But then you implement it with a auto tube cleaning system, because this serves one purpose, that serves another purpose, right? And what we have seen is that from auto tube cleaning system, if your saving potential is 5%, and by this chiller controller it is 8%, so your overall savings are not 5 plus 8, but it is even higher in some of the cases.
Okay. So now let's move forward, and we have the last question of the session, and it is from Mohammad Zakir Hussain, and he's saying that thank you for your nice presentation. Now my question is that is low loading causes efficiency of energy efficient motor goes down. Is there any graph for loading versus efficiency or of energy efficient motors?
Oh yeah, definitely. In Google right now, you can give percent loading versus motor efficiency. You will get that graph. And don't look at the normal search of the Google. Straight away go to the images, right? In image category, you'll find that graph. Like what I have shown, that was for size of the motor, right? With different size of the motor, how IE1 to IE5 efficiencies are changing. The same graph you will get it for percent loading, right? It's very much there.
Okay, sir. Thank you so much for your time, sir. And let's move move forward. And now I would like to present my vote of thanks to the speakers, Mr. Lalit Tiwari and Mr. Milind Chittawar, for joining us today for the session. And thank you, everyone, for being present, all the participants. And I hope you all have learned something here. Let's just end this here. Thank you so much for joining us today. And take good care of
Bye,
yourself and
everyone.
the environment.
Yeah,
Bye,
thank you,
everyone. We hope
Milinji.
you all enjoyed.
Thank you. Yeah,
Thank you.
thank you, Milinji, and thank you, Asta, for
Thank you
conducting
so
this good program here.
Thanks.
Yeah,
Bye,
thanks.
everyone. Bye-bye.
Bye.
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 much. Bye.